So hello guys, welcome back to my channel, and those who are new to this channel, kindly make sure that you subscribe to this channel for the latest tech updates and the tech knowledge. So today is day 11 of the 20 days of the statistics course, and today we're going to talk about the sample distribution and the central limit theorem, which is a very popular theorem, okay, and useful also. So let's start. So in real life we rarely have access to the entire problem. For example, we don't measure the heights of all the people in a country, right? But we calculate the average height of the Indians. We don't ask every customer for the feedback, but we come to a conclusion about the feedback of the customers. We don't test every manufactured item, but we just take the sample of it and then test it, and we you know uh, give the conclusion of the entire batch. So instead, we take the samples, okay, and try to understand the population from them. But this raises an important question. If we take different samples, will we get different averages? And the answer to this is yes. And this leads to the idea of sampling distribution. So, sampling distribution is nothing but the distribution of the statistics, usually the mean, calculated from many different samples drawn from the same population. Okay, so let me write this for you about the sampling distribution. So it is nothing but the distribution of a statistics. Think of it like take a sample, compute the average, take another sample, compute the average, and repeat this many times. Now plot all these averages, and the distribution you get is the sampling distribution of the mean. So the key insight we draw from here was that individual data points may vary a lot, but the sample averages vary much lesser. Okay, so let me write that for you also. Like we take a sample, then we compute the average. Then we again take the sample, then again compute the average. Okay. Then we repeat like many times. Okay. We repeat this many times, and now like plot all these averages on a graph. And the distribution you get is the sampling distribution. Now let's talk about the central limit theorem first, okay? Now we'll be talking about the central limit theorem. So, a central limit theorem states that as sample size increases, the distribution of sample mean approaches a normal distribution regardless of the original population distribution. So, this is incredibly powerful. So, if your data is like skewed, uneven, or non normal, the average of sample becomes normal. So when sample size is sufficiently large, typically n is should be like roughly greater than or equal to 30, because the average of sample becomes the normal. So this is like, why do averages become mean? Uh, Sorry, why do averages become normal? So this is the part that average audience say, now I get it. Okay, So each sample mean is formed by averaging many independent observations. Okay, so when many independent effects combine, the extreme values just cancels out and the random fluctuations are balanced. So the result stabilizes around the sample. In simple words, I must say that averages reduces the randomness. Averaging reduces randomness. Okay, and extreme highs and lows get smoothed, reducing the bell-shaped curve. The real life example, I must say, like imagine rolling a dice. So on a single roll you get values from 1 to 6, that is a uniform distribution. Okay, and on the average of 2 rolls you are more centered, and the average of 10 rolls strongly centered near 3.5. So if you repeat these steps many times and plot the averages, you will get a bell curve. So original data was not normal, but the averages become normal. So why do we use like central limit theorem, and why is it like so important in data science? Because central limit theorem is the foundation of, let me write this, it is the foundation of first confidence interval. Second, hypothesis testing. Third, A/B testing. Fourth would be model evaluation. And the fifth is the statistical inference. We do, okay? Statistical inference. So individual data can be messy, but averages behave predictably. So the central limit theorem explains about the why scenario. Okay, it explains about the why situation. So that's all for this, about the sampling distribution and the central limit theorem. Like, it's just the name suggests, you can take it so commonsensically that the central limit theorem, it limits the value to the central value, like the bell shaped curve in the normal distribution. Because one sample is very uniform, like I gave you the example of the dice, right? And if you like take the averages of all the samples, then you will get a normal distribution curve. So we often use central limit theorem, and it is useful in like hypothesis testing, A/B testing, and the confidence intervals and all. So if you like the content of this video, just like this video, subscribe my channel, and do not forget to hype my video just to keep me motivated. And meet you in the next video, that is the day 12 of the 20 days of the data science course, like the 20 days of the statistics. Meet you in the next video. Till then, bye bye.